I was doing a bit of a digital spring clean the other day,
Yeah.
clearing off an old hard drive that I probably haven't touched in, I don't know, 5 or 6 years.
Mm.
And I stumbled into this old software folder. I honestly couldn't even remember what the program did.
Uh-huh.
But before I could click on anything or even try to figure out the file structure, I saw it. That one file sitting right at the top of the list, just screaming at me in all capital letters.
Let me guess. README.
That's the one. README. Not instructions, not guide, just a command. README. It feels so aggressive, doesn't it?
It is imperative. It's loud.
Like the developer's reaching through the screen and grabbing you by the shoulders.
And let's be honest, it's a file that everyone sees, but if we're being real, most people just completely ignore.
Oh, absolutely.
Oh, yeah.
I'm so guilty of it. I usually just double-click the application icon and hope for the best. If it breaks, then maybe I'll go look at it.
Right. It's the last resort.
But that moment got me thinking, why is it there? Why is it shouting? And how has this specific file survived from the days of massive mainframes all the way to, the modern web?
Well, it's about time someone stopped to ask.
So today on the deep dive, we are stopping to actually read the README.
It's funny you mention ignoring it because that file is, it's the cornerstone of software documentation. It's the Rosetta Stone for understanding what you just downloaded.
And we're going to unpack its history. And based on the research we pulled together, mostly from a really comprehensive Wikipedia breakdown, this story is, well, it's wild. It involves Lewis Carroll, stacks of punch cards from the 70s, and the entire open source web.
It really is a journey through computing history, just disguised as a simple text file.
Okay, so let's start with a mission statement. If I'm a developer in 1975 or 2025, why am I creating this file? What is it actually for?
At its most basic, the README is an orientation device. Think of it like walking into a massive dark warehouse. You don't know where the light switch is. You don't know where the exit is.
And you don't know if there are holes in the floor.
Exactly. The README is the sign right at the entrance that hands you a flashlight and a map. It's the "you are here" sign for a directory.
So it tells you what the software is, what all the other files are for, and crucially, what not to touch so you don't break everything.
Precisely. And there's a kind of golden rule that goes with it.
Oh, what's that?
It's the rule of thumb that every sysadmin knows by heart. If you are unfamiliar with the directory, you read this file before you run anything else. It's not a suggestion, it's a failsafe.
Which brings us back to the name, READ, in all caps.
Yeah.
Is it just frustration? Is the developer basically saying, I know you're going to ignore this, so I'm just going to yell at you?
It feels emotional, right? But it's actually purely technical. It's a hack.
A hack.
A really clever one. To understand why it screams, you have to go back to the early days of Unix systems.
Okay, set the scene.
So imagine a terminal screen. No mouse, no icons, just lines of text. In those early Unix environments, file names were pretty much all lowercase.
Right, main.c, config.sys, that kind of thing.
Exactly. It was just the culture. Everything was lowercase to save keystrokes. Now, computers sort files based on something called ASCII order.
The character codes.
Yeah. And in the ASCII table, capital letters are sorted before lowercase letters.
Oh, I think I see where this is going. It's about the sort order.
You nailed it. If you named your file README in lowercase, it would just get buried in the middle of the list, lost in the noise. But if you name it README in all caps,
the system is forced to float it right to the very top of the directory listing.
Yep.
That is such a brilliant, low-tech UI hack. They were capitalizing for visibility, not for emphasis.
It's ingenuity born of limitation. They didn't have a pin-to-top feature, so they used the alphabet itself. And that convention was so effective that it stuck.
And we still see variations, right? Like readme.txt or more often now readme.md.
Sure, for plain text or for markdown. But that core idea, the capitalized name, has survived for 50 years.
Speaking of 50 years, I want to get into the origins. Because when I was reading through the material, I expected the history to start with, I don't know, MS-DOS. But it goes back way, way further, and it gets surprisingly literary.
This is my favorite part. The source cites the New Hacker's Dictionary, which is basically the folklore Bible for computer science.
Okay.
And when you ask the old school hackers where the README convention comes from, they don't talk about sorting algorithms first. They talk about Alice's adventures in Wonderland.
Wait, what? Lewis Carroll?
The very same. Think about when Alice falls down the rabbit hole. She finds a little cake and a bottle. What's written on them?
Eat me and drink me.
Exactly. Simple, direct imperatives written on an object that tell you exactly how to interact with it. Early hackers loved that playful, direct instruction.
So it's a little literary inside joke. Here's the magic potion. Read me to enter this weird new world.
It's that intersection of whimsy and utility that really defined early hacker culture. But if we want to move from literature to actual hardware, we can pinpoint its appearance pretty specifically.
The source mentions a date, November 27th, 1974.
Right. This is the PDP-10 era. We're talking mainframe computers that took up entire rooms.
No screens, just teletypes and blinking lights.
And there's an archive record from a PDP-10 mainframe from that day. It was a fail-safe tape, a backup tape, with a circuit analysis program called SPICY. And right there on the tape, a file called readme.txt.
1974. Wow. So what was in it? Just good luck.
Actually, pretty similar to today. It described dependencies. It noted the software required Fortran 10 version 4. It listed memory requirements, about 47K.
47 kilobytes.
Which was a massive amount of memory back then, but the message was the same. Before you try to load this tape and waste expensive computer time, make sure your machine can handle it.
It's amazing how the problems stay the same just with more gigabytes.
Yeah.
But there's an even more physical origin story mentioned, right? Before files on a tape.
Yes, the tactile history we always forget. Before screens, programmers used punch cards.
Stacks and stacks of stiff paper cards with holes in them.
So your program isn't a file, it's a literal cardboard box with maybe 2,000 cards. If you drop that box, you've ruined your week.
So how did you label it?
You take a piece of paper, attach it to the top of the deck with a rubber band, and on that top sheet you'd print README in huge block letters.
A literal physical README.
Exactly. It had the instructions, load this deck first, or this is the data, this is the program. It was the cover sheet. When we moved to digital files, that physical cover sheet just became the first file in the directory.
That makes so much sense. And it even crossed over into the consumer world with the first Macintosh, right?
It did. The early Mac system software disks included a README, which is important because it shows the convention jumping from the high-level engineers down to the average person. It became the way to say, here's late-breaking info that didn't make it into the printed manual.
Right, because once the manual is printed and in the box, you can't change it. But you can change the file on the disk at the last second.
Exactly, the original day one patch.
Okay, so we know where it came from. Let's talk about the anatomy. If I open a README today, what am I looking at? Is there, like, a README police that enforces the rules?
I wish there were README police sometimes. But no, the source says there is a total lack of formal standardization. It's the Wild West.
That sounds chaotic.
It can be. But conventions have emerged over time, especially from groups like the GNU Project. A really good README today usually has a standard checklist of things.
Okay, walk us through the checklist. What do I need?
First, the manifest. That's just a list of all the files in the directory. It was crucial in the old days to check for disk corruption.
I have 5 files. The list says 6. Houston, we have a problem.
Exactly. Next, and most importantly, instructions. How to configure, install, and operate it. This is where most bad READMEs fail. They assume you already know everything.
The curse of knowledge? Then, the legal stuff.
Always. Copyright and licensing. Can I copy this? Can I modify it?
Yeah.
In the open source world, if you don't state the license, no one can legally touch your code.
And then the part no one wants to admit, the problems.
The bugs section. A good README lists known issues. It's all about managing expectations. It tells you, we know this feature is broken, we're working on it.
That's actually reassuring. If I find a bug and it's listed, I feel like, okay, they know. If it's not, I assume I broke it.
Right, or that the developer's incompetent. It builds trust. Now, there is an interesting nuance here because a README is often talking to 2 different groups of people.
Oh, who are groups?
You've got the users and you've got the developers. For example, a news section is for the user. It says, now features a new dark mode. It's high level.
And the other one?
A change log. That's for the programmer. It's super detailed. Fixed memory leak in line 400 of the kernel. The README has to serve both.
It's talking to the user, the lawyer, and the developer all at once.
Which is why sometimes one file just isn't enough. And the README explodes into what we can call the extended universe of files.
The extended universe. I like that. Because, yeah, at a big project, there's a whole family of these shouting all-caps files.
You split the burden. So you get authors, which is just a list of who wrote the code. You get thanks, which is for acknowledgments.
The credits roll?
Pretty much. Then you have install. If the instructions are super complex, you'll see copying or license for the full legal text.
I've seen one called Toto.
That's the roadmap. A wish list of planned changes or features.
Okay, there's one file name I've always found funny, and the source mentions it. Hacking. When I see that, I feel like I'm about to learn how to break into a bank.
I know, it sounds so nefarious now. But this is where context is key. In the open source world, hacking uses the old school MIT definition. It just means playful, clever programming.
So it's not how to steal passwords.
No, not at all. A hacking file is a guide for contributors. It says, if you want to modify this code, if you want to hack on it, here are the coding standards and style guides you need to follow.
It's an invitation to collaborate.
Precisely. And they're all in caps, all shouting to be seen at the top of the pile.
So we've gone from punch cards to text files. But the way we get software has changed so much. We go to GitHub now. How did the README survive that shift?
This is the plot twist. The README hasn't just survived, it has become maybe the most important marketing asset a piece of software has.
Marketing. That's a huge leap for a little text file.
Think about it. When you go to a project's page on GitHub, what's the first thing you see below the file list?
The description, screenshots, badges, all that.
That is the README. GitHub automatically finds it and renders it right there on the front page. It turns the text file into the project's homepage.
Oh, right. That whole section is just the README.
That's it. And that changed the game. Suddenly, the README wasn't an instruction manual you read after you downloaded something. It became the landing page you see before you download.
Wow. That is a huge psychological shift. It goes from user guide to sales pitch.
Exactly. It's the face of the software now. If a project on GitHub has a messy or blank README, people assume the code is messy. They just click away.
And they can look really nice now. It's not just blocky text.
Right. That's thanks to Markdown, the MD in README MD. It lets you add formatting, links, images. GitHub basically turns it into a rich web page.
So it's still just a simple text file for the developer, but it looks like a professional website to the user.
And this has brought in this new idea of community health.
Community health. You mean like, is the project alive or dead?
Pretty much. A good README, a contributing file, a code of conduct. They signal that a project is healthy, active, and welcoming. If they're missing, it feels abandoned.
That evolution is just incredible. From a piece of paper on a stack of punch cards to the multimedia homepage that determines the social health of a global software project.
And yet, the core function is still the same. It's about context. It's about fighting chaos.
Let's unpack that a little. Because in a way, the README is the only thing standing between the user and total confusion.
It is. Information without context is just noise. A folder full of files like by86driver.dl is meaningless unless you know what they do.
The code makes it work, but the README makes it usable.
Precisely. It's the human element in the machine.
So we've traveled from the PDP-10 to the modern web. We learned the all caps isn't anger, it's just sorting. And that Lewis Carroll has a surprising amount of influence on all this.
Eat me, drink me, read me. Simple instructions for complex worlds.
As we close out, I want to leave you with a thought. We've been talking about software, but you mentioned the README provides context in a chaotic system.
It's an operating manual for the unknown.
Right. So here's the question. In our own lives, in our workplaces, we're constantly overwhelming people. We drop huge project files on them, we add them to complex teams, and just expect them to figure it out.
We give them the directory, but not the README.
Exactly.
Ooh.
We assume they know the context.
Yeah.
So do we need to start writing READMEs for ourselves? A README MD for how to work with you.
That's actually a brilliant idea.
Here are my known bugs. I'm grumpy before coffee. Here's my changelog. I just learned a new skill. Here is how to install me into a new project.
A user manual for me? It would solve so many configuration errors in office communication. If everyone came with a README, we'd probably misunderstand each other a lot less.
Something to think about the next time you open a folder and see that file shouting at you. Don't ignore it. Read it. It's trying to help.
It's the most important file in the folder.
Thanks for listening to The Deep Dive. We'll see you next time.